set GID and directories. The set UID has no effect on directories. Set GID does and causes any file created in a directory to inherit the directory's group owner. It is useful if users belong to other groups and routinely create files to be shared with other members of the group instead of manually changing its group. So that's a difference, or that is the correlation between set GID and directories. Then we have discussed before about kernel space and user space. Kernel space refers to memory used by Linux kernel and the loadable modules like your device drivers. The user space refers to memory used by all other processors. Since kernel enforces Linux DAC and security, it is extremely critical to isolate the kernel from user space. For this reason, kernel space is never swapped to the disk. Only root may load and unload kernel modules. Mandatory access control. Now, discretionary access control model, we have seen the owner of a given system object can set whatever access permission on that resource he or she likes, right? So that is DAC security model. The user who creates a file on the Mac system, Mac is mandatory access control system, generally may not set access controls on that file that are weaker than the controls dictated by the system security policy. In Mac based system, the only thing is that the super user account is used for maintaining the global security policy. Day-to-day system administration is performed using accounts that lack or do not have the authority to change the global security policy. Now, as a result, it is impossible to compromise the entire system by attacking any one process. To create an effective global security policy requires detailed knowledge of the intended behavior of the application. So, the Mac systems have been very hard to manage. Now, furthermore, the more restrictive the security controls are on a given system, it will be less convenient for the users to operate on. So, there should be a proper balance between security and usability. So, now the Mac or mandatory access controls impose a global security policy. We have already discussed that. Novell's SUSE Linux has got AppArmor. Red Hat Enterprise Security has SE Linux. Now, pure SE Linux for high sensitivity, high availability. That is what SE means. Now, let's look at the evaluation between Windows and Linux designs. Now, it is possible that email and browser based viruses, trojans and worms are a source of myth that Windows is attacked more often than Linux. Do the attacks so often succeed on Windows because the attacks are so numerous? Or is it because there are inherent design flaws and poor design decision in Windows? Many, if not most of the viruses, trojans, worms and other malware infect Windows machine through vulnerabilities in Microsoft Outlook and Internet Explorer applications. In most cases, where the Linux systems are compromised, the primary cause was inadequately configured security setting. Windows has evolved from a single user design to a multi-user model a few years back. Windows is monolithic, means it is not modular by design. Windows depends too heavily on the RPC model. We'll see what is RPC model. Windows focuses on its familiar graphical desktop interface. Now, what does it mean that it is evolved from a single user design to a multi-user model a few years back? Windows has long been hampered by its origin as a single user system. So, when it was Windows a few years back, we say, oh, it's excellent for a desktop. Windows was originally designed to allow both users and applications free access to the entire system, which means anybody could tamper with critical system, program and file. XP was the first version of Windows to reflect a serious effort to isolate users from the system, so that the users each have their own private files and limited system privileges. This caused many legacy Windows applications to fail. So what the solution was? Windows XP includes a compatibility mode, a mode that allows program to operate as if they were running in the original insecure single user design. XP represented progress, but even XP could not be justifiably referred to as a true multi-user system. Now again, when we spoke about monolithic by design and it is not modular, what does it mean? Monolithic design means one where most features are integrated into a single unit. So Microsoft successfully makes competing products irrelevant, or it makes the competing products irrelevant by integrating more and more of the services they provide into the operating system. But this approach creates a monster of inextricably interdependent services. Interdependency side effect is also there. Every flaw in a piece of the system is exposed through all of the services and applications that depend on it. Then it is unstable by nature. When you design a system that has too many interdependencies, you introduce numerous risks when you change one piece of the system. So it affects the entire system itself. Thus, monolithic system tends to make security vulnerabilities more critical than they need to be. They depend heavily on the RPC model. RPC stands for remote procedure call. Simply put, an RPC is what happens when one program sends a message over the network to tell another program to do something. RPCs are potential security risks because they are designed to let other computers somewhere on the network to tell your computer what to do. Unfortunately, Windows users cannot disable RPC because Windows depends on it. Even if your computer is not connected to a network, RPC is required for Windows. Now, the most common way to exploit a RPC related vulnerability is to attack the services that use the RPC, not RPC itself. Then Windows focuses on its familiar graphical desktop interface. Microsoft considers its familiar Windows interface as the number one benefit of using a Windows server, whatever version. Now, there is a quote from Microsoft website. With its familiar Windows interface, Windows Server, whatever version, is easy to use. New streamlined wizards simplify the setup of specific server roles and routine server management tasks. Now, by advocating this type of usage, Microsoft invites administrators to work with the Windows Server at the server level itself, logged in with the local administrator privileges. This makes Windows Administrator most vulnerable to security flaws because using vulnerable programs such as IE exposes the server to security risks. When you come to Linux design flaws or poor design decisions, Linux is based on a long history of well fleshed out multi-user design. Linux is modular by design. Linux does not depend on RPC to function, and services are usually configured not to use RPC by default. Linux servers are ideal for headless non-local administration. What does that mean? Linux does not basically have a history of being a single user system. Therefore, it has been designed from the ground up to isolate the user from applications, the files, the directories that affect the entire operating system. Each user is given a user directory where all of the user data files and configuration files are stored. When a user runs an application, such as a word processor, the word processor runs with the restricted privilege of the user. Now, what is important here is Linux provides almost all capabilities such as rendering of JPEG images as modular libraries. As a result, when a word processor renders a JPEG image, the JPEG rendering function will run with the same restricted privileges as the word processor itself. If there is a flaw in the JPEG rendering routine, a malicious hacker can only exploit this flaw to gain the same privilege as the user, thus preventing potential damage. That is the benefit of modular design, and it follows more closely the spherical analogy of an ideally designed operating system. Given these default restrictions in the modular nature of Linux, it is nearly impossible to send an email to a Linux user that will infect the entire machine with a virus. Linux is for the most part a modularly designed operating system from the kernel to the applications. The kernel is, again, we emphasize, the core or brains of Linux. Not everything in Linux is also modular. There are two most popular graphical desktops, Genome and KDE. They are somewhat monolithic by design. The Linux kernel supports modular drivers, but it is essentially a monolithic kernel where services in the kernel are interdependent. An adverse impact of this monolithic approach is minimized by the fact that the Linux kernel is designed to be as minimal as a part of system as possible. Now, Linux follows a philosophy almost to the point of fanaticism. Whenever a task can be done outside the kernel, it must be done outside the kernel. This means that almost every useful feature in Linux, now useful here is as perceived by the end user, is a feature that does not have access to the vulnerable parts of the Unix system. It is not constrained by an RPC model. So most Linux distribution install programs with network access turned off by default. So even when Linux applications use the network, they are most often configured to respond only to the local machine and ignore any requests from other machines on the network. Unlike Windows Server, you can disable virtually all network related RPC service on a Linux machine and still perfectly have a good functional desktop. It is ideal for headless non-local administration. Now, a Linux server can be installed and often should be installed as a headless system, that is, no monitor connected, no keyboard connected, no mouse connected, and administered remotely. Often the ideal type of installations for servers, because a remotely administered server is not exposed to the same risk as locally administered server. This may be one of the most important differentiating factors between Linux and Windows, because it virtually negates most of the critical security vulnerabilities that are common to both Linux and Windows systems, such as vulnerabilities of the Mozilla browser versus the Internet Explorer browser. So you can't run a Mozilla browser on a server. Let's take a look at Windows vulnerabilities. Some of them at least. Windows, like any other OS, has security bugs. Bugs have been exploited to compromise customer accounts. There are multiple versions of Windows, and each of the versions with a substantial user base. And attackers are now more organized, or they are organized criminals. They are highly motivated by money. Microsoft security bulletin summaries and webcasts provide latest vulnerability list and relative security updates and status. Now, some example we'll look at what kind of vulnerabilities are coming. Vulnerabilities in Windows kernel could allow elevation of privileges, that is in 2010. What this particular vulnerability does, most severe of these vulnerabilities could allow elevation of privileges if an attacker logged on locally and ran a specifically crafted application. An attacker must have a valid logon credential and should be able to log on locally to exploit this vulnerability. This vulnerability could not be exploited remotely or by anonymous users. Now, this is where the fundamental difference between Windows and Linux come in. The system administrators in a Windows system log on locally, use it like a desktop, install untrusted applications, introduce unknowingly viruses, trojans, or other malware into the system. So this is exactly an example of why a headless system is required. Another one, vulnerabilities in Windows kernel could allow elevation of privileges. Security update resolved several privately reported vulnerabilities in Microsoft Windows. Now here what basically happens is a denial of service condition, and this particular vulnerability affects almost all versions of Windows, that is Vista Service Pack 2, Server 2008, Windows 7, Microsoft Windows, release to R2. So again, most likely it will result in a denial of service condition. Linux vulnerabilities. Now, default Linux installations, that is unpatched and unsecured systems, have been vulnerable to buffer overflows, race conditions, abuse of programs, that is run set UIDs and run set GID, denial of service, web application vulnerabilities. Why web application vulnerabilities have come here is because most of the web servers which are running, the big ones, run on some version of Linux. Then rootkit attacks. We'll look into all of those. First, let's look into buffer overflow. What is a buffer overflow? Buffer overflow occurs when attackers intentionally enters more data than a program was written to handle. That is what a buffer overflow means. As a user, it is the best thing to do is to take away the ability for the vulnerability to be exploited by what is known as patching the system properly and to know what programs are in use. So, buffer overflow have always been associated with security vulnerabilities. In the past, a lot of security breaches have occurred due to buffer overflow. Now, it occurs when the attacker intentionally enters more data than a program was written to handle. We have seen that. The extra data overwrites on top of another portion of the memory that was meant to hold something else, like a part of the program's instructions. This allows the attacker to overwrite data that controls the program and can take over control of the program to execute the attacker's code instead of the original program. It is perfect for remote access attacks because they give the attacker a great opportunity to launch and execute their attack code on the target computer. Now, as a user, the best thing to do is to take away the ability for the vulnerability to be exploited by knowing what programs are in use and keeping the patches up to date. We have already discussed this. We look at set UID root vulnerabilities. As we discussed earlier, when set UID permissions bit is set, the programs will run with the privileges of the user that owns it rather than those of the process or user that is executing it. So, set UID root program is a root owned program, runs as root no matter who runs it or who executes it. If set UID root program can be exploited or abused in any way, for example, if it can be exploited via a buffer overflow or a race condition, then the unprivileged user can gain access to unauthorized privileged resources. So, running set UID is necessary for programs that need to be run by unprivileged users. Yet, it must provide such users with access to privilege function. For example, changing their password, which requires changes to the protected system file. So, such programs must be programmed very carefully. Due to the history of abuse against set UID root programs, major Linux distributions no longer ship with the unnecessary set UID root program, but system attackers can still scan for them. Then comes web application vulnerabilities. It is a very broad category of vulnerability. As we know, web applications are written in scripting languages such as PHP, Perl, Java. So, it may not be prone to classic buffer overflow, but it can suffer from poor input handling, including XSS, SQL code injection, and Linux distribution shipped with few enabled by default web applications like default CGI script included with the Apache web server. Then comes the rootkit attacks. This is a kind of attack which allows an attacker to cover his or her tracks, typically after a root compromise. So once you get root, then you try to erase your tracks from the system. So it allows the attacker to cover his or her track, which occurs after a root compromise. Now, rootkits begin as a collection of hacked replacements for some common Unix commands, like ls, that behave like legitimate command that they replaced, except for hiding an attacker's file directory or processes. For example, if an attacker were able to replace the compromised Linux system ls command with a rootkit version of ls, then anyone executing the ls command to view files and directory would see everything except that attacker's files and directories. Now, since the advent of LKMs, loadable kernel modules, rootkits have more frequently taken the form of LKMs. So, a LKM rootkit covers the track of attackers in a kernel space and intercept system calls pertaining to any user's attempt to view the intruder's resources. Luckily, LKM rootkits are not completely invisible. So many traditional LKM rootkits are detectable with script chk rootkit. It's available at www.chkrootkit.org. Check rootkit.org. However, the attackers can get far enough. If at all they compromise the system, then we'll have to wipe and rebuild the entire system. Now, what are the means of evaluating metrics between Windows and Linux? The severity of security vulnerabilities are derived from the following metrics. What is the damage potential? How much damage is possible on the system? Exploitation potential. How easy is it to exploit? Exposure potential. What kind of access is necessary to exploit the vulnerability? Then the overall severity risk. Given the above three factors, that is damage potential, exploitation potential and exposure potential, the overall severity risk range from minimal to catastrophic. Now, if you take an example, Windows or Microsoft often ranks a security flaw as critical for all Windows operating system except the Server 2003, in which case it is ranked at a lower value, which is important. The reason given for this difference is that 2003 has a different default setting than other versions of Windows. This is an example of a Microsoft security bulletin where the vulnerabilities are listed. You can see it is critical remote code execution, critical remote code execution, important remote code execution, so etc. Then aggregate severity rating, critical, important. So the security bulletin looks like this. Now, Computer Emergency Response Team, CERT, US CERT, comparing query results for Microsoft and Linux keywords. So, when you are evaluating Windows versus Linux vulnerability, the US Computer Emergency Readiness Team uses its own metrics to evaluate the severity of any given flaw. Now, I query CERT vulnerability node database for Windows and Linux keywords to examine metrics for the 40 most recent reported vulnerabilities. A number between 0 and 180 expresses the final metric, where the number 180 represents the most serious vulnerability. This ranking is not linear. In other words, a vulnerability ranked 100 is not twice as serious as a vulnerability ranked 50. So you get the point there. CERT considers any vulnerability with a score of 40 or higher to be serious, to be a candidate for special CERT advisory and US CERT technical alert. Now, when you do a query result for Microsoft, it lists out all the potential vulnerability. I have taken from the oldest to the new ones. So I have taken a pretty old one for the presentation here. Similarly, when I do it for Linux, I get a similar thing. CERT web search capabilities do not provide or produce perfectly desirable results in terms of granularity or longevity. It is especially true for Linux because the Linux search results includes a number of Oracle security vulnerabilities that are common to Linux, Unix and Windows. So in top 40 CERT result for Windows, the top entry containing the severity metric of 78, there were 5 entries which had a severity rating of 40 or greater. And in top 40 CERT results for Linux, the top entry containing the severity metrics of 26.52 and no other entry has a severity rating of 27 or greater. So you can see the difference. Note that the CERT results only reflect how Windows security flaws tend to be far more frequently severe than those of Linux. These results cannot be expected to mirror our own analysis of frequent or recent vulnerability patches.